Okay, so in this talk we will talk about the enhancing transparency in biomedical research, in particular addressing the non-publication of negative preclinical results. This talk is based on a publication that we did last year, 2024, about a survey in which we asked animal researchers which was their views on the publication of negative results and why they would benefit from that, and which policy adoptions would be useful to enhance this transparency. So first of all, let us define negative results. So very often we compare different groups, or we compare the proportion of animals that get infected with when using a vaccine with respect to a reference value. So at the end, there is always an hypothesis test, and in this hypothesis test, depending on what is the p-value, we put a number of stars or a number of evidence how much the experiment supports the fact that the two control and treated groups are different, or the vaccine is useful. So depending if the p-value is very small, then there is a lot of evidence that the treatment is useful. If the p-value is large, then there is no evidence, at least with this experiment, that the treatment is useful. And these experiments with large p-values are the ones that we refer to. So those are a negative result. So the treatment didn't show to be useful. And here we have an example in which there is a small difference between the two, but the difference is not statistically significant. So if the result is positive, so the p-value is smaller than typical threshold 0.05, then we normally at some point we may publish the results. But if the result is negative, the p-value is larger than 0.05, normally we never publish this, and the experiment is stored in a file drawer, so it is never published. So this concern about publication, about only publishing positive results, is what is called publication bias. It is a concern for a very long time. Here I'm just showing one of the papers that talk about it, and in this paper they estimate that 50% of the animal experiments are published, so the other 50% are never published, and the reasons for not publishing are the lack of statistical significance, technical problems with the experiment, or influences from supervisors and peer reviewers. And this non-publication of negative results leads to a biased literature base. So in the literature you only see the positive results, you never see the negative results. So the authors of this paper suggest that there should be a mandatory publication of study protocols and results in disregarding whether the result is positive or negative, and they also raise the concern that this publication of negative results there could increase the bureaucracy. The editorials of these two important journals, Science and Nature, they also are concerned about this publication bias and this prevalence of positive results and never seen the negative results, and that they are concerned that because underreporting, because the negative results are never published, there is an incomplete understanding of certain research areas. And for instance, in this paper, this editorial of Nature in 2020, they advocate for a cultural shift in the scientific community to recognize and to reward the replication studies that are also normally not published and the null results. So this publishing, replication, and null results would enhance the robustness and reliability of scientific research. So we conducted a survey. We were also concerned about why people are not, or researchers are not publishing these negative results, and what we could do about it. And then we made a survey that the full survey and all the details are given here in this link. And this survey was to researchers that were working with animals in their research studies, and we surveyed their so the respondents were 241, and the main so I'm highlighting here the main population. So most of them were established researchers in the academic world, many of them from Spain, because we started this study from Spain. Then many of them were female. Number of articles of the majority was somewhere between 0 and 10. They had 0 to 10 years of experience working with animals. Most of the animals were mice. Normally they didn't pre-register their study before doing the experiment. Then the proportion of negative results that they estimate is about 32%, so about 1/3. Before we saw in that paper about a half, so somewhere between 1/3 and a half. And they decided not to publish these negative results in about 40% of these negative results. They were published only 25, so somehow this so 75% of the negative results are never reported, and the sharing of negative results would benefit their study because they would avoid repetition. There would be valuable knowledge in those negative results, and it would help to reduce the number of animals used. And also they would benefit from other researchers' negative results because they could see which were the problems that these other people were having and try to avoid those problems in their own studies. So the causes for them of these negative results were a true lack of effect, so the treatment is not really useful. The variability, so when you are comparing two groups, the two groups might be too variable. So if there is a difference between the two, it is hidden by the level of noise, and this is somehow also related to a low sample size. So if the data is variable, or more or less variable, but you have a big enough sample size, you would be able to detect what is the difference between the two. And animal or environmental factors, that somehow is again another version of variability for unknown reasons, random chance, poor execution of the experiment, poor hypothesis from the beginning, poor compliance to guidelines. So you see that there are many important reasons why you could have a negative result, and it is not only that the treatment is not useful. And the reasons for not publishing the negative results, the most important reason is the low success in trying to publish them. So if you try to publish one of these negative results paper, normally it is rejected. Because there is a lack of culture of publishing negative results, there is an absence of journal that accepts these kind of studies. They get a low number of citations, so they are not so incentivized to publish these negative results. There is no incentive, so institutions do not promote the publishing of negative results. They cannot decide to publish it or not because they depend on other people, and they're afraid of showing negative results. they're unwilling to go to a full peer review process, which is long, it is painful, and at the end, very likely it will be rejected. They are not obliged, so they don't feel compelled to do it. They're afraid of having a bad design and showing to the world that they have done a bad design of their experiment. Some of them think that it is not useful, they don't have enough time, they're unsure whether the result is really truly negative or it is just a mistake in their design, their execution. There are pressure from collaborators not to publish that, or some legal constraints, but these legal constraints, you see, it is a minor concern with respect to all the others. So the policies that they request to publish these negative results is that they think that the scientific societies should promote the publication of negative results. The funders should require that. Also, the institutions. Half of them think that the researchers should decide whether to publish it or not. Not a minority, but 40% of them think that the researcher should be rewarded, or the laboratories should be rewarded for publishing these negative results, and that the researcher evaluation should consider having published negative results as a positive value in this researcher when evaluating a particular researcher. And the request that they have for a location to publish these negative results is that it should be easily discoverable, can be cited, there is a quality control before publishing, it is easy to navigate and to submit, it is free to publish, there is a full paper in peer-reviewed journal. It is hosted by a recognized institution. There is a peer review control. It is freestyle, non-peer reviewed repository. So you see, they prefer the standard way to publish rather than something new. But this something new is also something that is widely supported by almost 60% of people. It allows comments from readers, as many other journals now do, and somehow it is collected in an open science database. The problems, but there are also problems associated to this publishing of negative results. So one of the main ones are that there are fake submissions if there is a non-peer review. If there is a non-peer review, so if it is not revised by anyone, reviewed by anyone, they think that there could be fake submissions from associations against animal research or any other reason. There is a low quality in the submissions if it is not peer review, so you see that peer reviewing is something that they request, and still some experiments would be repeated. So even if the result was negative before, some other people may try to repeat exactly the same experiment, but there is an over-publication rate because just to inflate the CV, and some of them, but a minority of them, think that even if they publish the negative results, these negative results would have no use. Then on the other side, the benefits of publishing the negative results, they think that there would be important savings for their funders. They also think that publicly funded projects should always be reported disregarding of whether the result was positive or negative, simply because of the fact that it was funded by public money. And these negative results would have societal benefits. The participants, if you were one of the animals participating in the experiment, you as a participant would want the results to be published, independently of whether the researcher gets some positive evaluation, paper, citations, but ethically, you as a patient, you would want this to be published. And it is unethical not to publish. They would serve for better future hypotheses and experiments. You would avoid the repetition of experiments, and there would be economical and time benefits, reduction of animals, reduction of publication bias. So there exists some form that it is actually very much used in psychology, that is these register reports. So these register reports is aimed to reduce this publication bias and improve the research transparency. And it works in the following way. So before doing the data collection and the analysis, you pre-register your study. So this pre-registration, you submit the experiment that you want to do, what are your hypotheses, what is your methodology, and which is your analysis plan. And it is peer-reviewed, and if it is accepted, then the journal commits to publishing the results independently of whether the result is positive or negative. And then once you have conducted your experiment, then you simply submit your results and your interpretations, and you have a final paper that is accepted because the pre-registration was accepted. And it has an interesting effect, that is the prevention of this hacking. Hacking is hypothesizing after the results are known. So let's say that you are doing an experiment with a treatment because you think that the treatment is useful, and then when you analyze the data, you recognize that it is only useful for women, and then your hypothesis now, and the one that you publish, is that you have made this experiment and you have discovered that it is a treatment useful for women. But this was not your hypothesis at the beginning. Your hypothesis was that it was useful for both men and women. It has been adopted by some journals like PLOS Biology or PLOS One, but there is a problem. The problem is that publishing these pre-registered reports costs a high amount of money that has to be taken from the project, and it has an impact on the experiments that you can do subsequently. So we saw before that one of the requests from the researchers was that it is free to publish these negative results. If we compare the pre-registration with another or the reporting of these positive or negative results to the situation in experiments with humans. In experiments with humans, the clinical trials, you have to register either in the US at the NIH your study before conducting it, or at this European Medicines Agency website. So you have to register your study before. We see that there is more than 500,000 studies at the clinicaltrials.gov. There are 45,000 clinical trials registered in Europe, and they really keep track of all the trials and make sure that the results at the end are always published, independently of what was the result. In animal research, we also have that. So there are a couple of sites that accept this pre-registration of the experiments, but you see the numbers: 200 for one of the sides, also 200 for the other side. So you can compare these numbers with the clinical trials, and actually there are many more preclinical studies than clinical, because many studies they stay at the preclinical state because they cannot go to clinical because the results are not so useful at the end. So these numbers, 200 compared to 500,000 or 45,000, they are rather small. And I haven't found the numbers of experiments that are done in Europe, for instance. The only thing I have found is the number of animals. The number of animals, you see, it is 9 million, and most of them are mice or fish, and so there are many more studies than these 200s. So actually now for the last few years it is compulsory to report to deposit something that is called the non-technical summary. So for all animal studies in Europe, you have to submit a non-technical summary to this database. So the number of studies you see here, it is 46,000. So there are a lot of studies. Most of them are not registered, and the results are never published. Actually, this non-technical summary is something that you submit before doing the experiment, so could be something that could be used to also attach the results of these studies, but someone needs to track them. And how to improve? So from the point of view of researchers, there should be an obligation to pre-register the studies, the same as now for the non-technical summary. There should be a thorough tracking of their status. So is the experiment being conducted, and if it is conducted, what are the results? And there should be a realistic way of publishing these negative results. Should be promoted by funders, should be promoted by European and national authorities or the institutions. And there are a number of benefits associated to this sharing of negative results. It would avoid redundant experiments. It would improve research design and hypothesis development for the future projects. There are ethical considerations associated to the maximizing the value of the data that has been obtained from an experiment, and try to reduce the number of animals in the future. It would reduce the publication bias and enhance the systematic reviews. So there are papers that work on the results of other papers, so these systematic reviews would benefit from having negative results. There should be it should enhance the scientific integrity and transparency, because the system, the research system would become more credible. There would be economic and time benefits, because you would avoid some experiments that are already known not to work. It would support open science and data sharing initiatives. For many algorithmic developments, you need positive and negative examples of what you are studying, and if you only have positive, your training of the algorithm is biased. And with this, I'm done. So the presentation was about how to avoid this file thrower effect of negative results that are never published. And with this, I would like to thank you all for attending, and I'm open to your questions.